Hey, Mr. Harrod, I'm here. I'm going to go over pH and pOH calculations, but we have to do a little talking before that. So first thing we have to talk about is the self-dissociation or self-ionization of water. Okay? Water can self-ionize. So this is self-ionization right here in this blank. Okay? Okay. What this means is water, to a very small extent, will dissociate into ions. Okay? It will form a very small amount of hydrogen ions, as well as hydroxide ions. Okay? So water has H plus ions, which make it act like an acid. And then water has hydroxide ions, or makes it act like a base. Okay, so water has the ability to act like an acid or a base. Okay, so water can self-ionize into the hydrogen ion. Now I know this shows you the hydronium ion. Remember, hydronium ion and hydrogen ion are the same thing. And hydroxide ions. Okay? This reaction is in equilibrium. What equilibrium means is that this reaction can go forwards and backwards. Okay? Equilibrium means that these reactions happen at the same rate. The amounts are not equal. The rates are equal. Okay? So since this reaction is in equilibrium, in AP you learned that you can write an equilibrium expression here for this reaction. And the equilibrium expression for this reaction would be H plus times OH minus equals 1 times 10 to the negative 14th. Okay? Remember, I can replace H plus with H3O plus because those are the same thing. Another thing here is that these brackets mean molarity. Moles per liter, right? Which was also used as the big M. Okay, brackets mean molarity. Okay, so what does this all mean for us? Acids release a lot of H plus in water solution, but since water is present, there's also OH minus in acids. Bases have OH minus in water solutions as well, but again, there's a small amount of H plus in it. So I'm basically telling you every amount of acids and bases, they all have H pluses and OH minuses in them. It's just that acids, why am I writing acid in blue? Acid solutions have more H plus and they have less OH minus. Okay? So the hydrogen ion is greater than the hydroxide ion. Meanwhile, bases have more OH minus and less H plus. If the solution is neutral, you have equal amounts of H plus and OH minus. Okay? Now, how this translates here is if you look at the pH scale, acids have a pH of 0 to 6.99 if you ask Mr. Harrod. Okay? Bases have a pH of 7.01 to 14. And my neutral solutions have a pH of 7. You can calculate out the amount of H plus and OH minus based off of the pH values. Okay, and we're going to show you how to do that in a little bit. Okay, on to the next page. Next page. Okay, the pH scale. okay, which I kind of went over. On the pH scale, acids classify as anything as having a pH of less than 7. Okay. A base classifies as anything as having a pH of more than 7. And if it's exactly 7, the solution is neutral. Okay. So if you look at this picture over here, you see there's a lot of H pluses here. There's more H pluses than OH minuses. So this is a picture of an acid. Okay, that's what acids look like. Because remember, all acids are dissolved in water, so that's why there is a small amount of OH in there. Notice that this one has lots of OHs in here, so this is a base. It has more OHs than H plus. Okay? Now, over here on the pH scale and the pOH scale, here's the first thing I need to do. No real chemist, fake chemist, whatever chemist you want to call them, you know, pseudo-chemist, whatever. There's no chemist that uses the pOH scale. I am crossing out the pOH scale. It just confuses people. So I'm crossing it out. Everybody focuses on the pH. Okay? So if the pH is 0, right, we're going to have more H plus and less OH minus. Okay? Because remember, on this end, this is the acid. Over here, this is the base end. So we're going to have more OH minus and less H plus. Okay. Now you can divide this into roughly 4 categories, 5 categories, depending on how you want to look at it. And the ranges of the numbers, they depend on who you ask as a chemist here. So if you're going from like 0 to 3.5, I would call those the strong acids. 3.5 to 7, those would be the weak acids. 7 to 10.5, these are the weak bases. And then 10.5 to 14, those would be the strong bases. And you can move these ranges depending on how you want to define the numbers. Okay. And then pH 7, that's the neutral. Okay. So the closer you get to the pH of 7, the weaker the acid or base is, depending on which side it is. Okay. Okay, let's look at example 8.6. Okay. 2 clear solutions are placed in separate beakers. Good for them. The first solution has a pH of 4, and the second solution has a pH that is unknown. 2 solutions are mixed together, and the resulting pH is 5. What do you know about the pH and the hydroxide ion concentration of the second solution compared to the first? Well, what I notice here is that the pH of the mixture increased. So we are becoming more basic since the pH rose. So the second solution has more OH than the first solution. So to increase the pH, you have to add a base. Okay, and bases have more OH minus. Okay, next example here. If the pH of a swimming pool is currently at a desired pH of 7.5, should you add more acid or should you draw more base? Well, you're trying to drop the pH to make it more watery, which would be pH 7. So to drop the pH, you must add an acid. There you go. Easily done. Okay, you guys are champions. The legend is out.